Good afternoon, everyone. Marjana, ma'am will take class from 2 p.m. Okay. Okay, ma'am. Okay. This is second experiment from my part. So the aim of the experiment is to observe the variation of potential difference V across a given resistance by changing current I through it. Draw IV graph and find the value of the given resistance from the graph. So this is the second experiment from my part. Before we start this experiment, first we have to know what is potential difference, what is electric current, and what is resistance, right? So do you have any idea about these three things? Do you have any kind of idea about potential difference, electric current, and resistance? Have you heard of these three topics?
Ma'am,
Yes.
potential difference, the difference of electrical potential between 2 points.
Yes, you can say like that also. Yes, correct. And what about electric current? Okay, so we know that when charges move from one point to another, it produces a electric current, right? So electric current is basically the rate of transfer of electric charge or rate of flow of electric charge. When the charges move, it produces electric current. Okay, so if in a system there are two amounts of charges which are flowing and the charges are flowing in a circuit in time t, then the electric current I of the system will be I equal to Q by T. That means when charges flows, it produces electric current. And potential difference is the thing which will cause the charges to flow. If there is potential difference is the difference between 2 points, right? If there is no difference, then charges will not flow from one point to another, right? So potential difference is the cause which will cause the charges to flow from one point to another. Potential difference is basically the work done in bringing a electric charge from one point to another in an electric field. So that is the difference of potential. And resistance in the thing which will try to oppose that current, which will try to stop that current. Every material has its own resistance, and we can apply resistance from outside also. So potential difference will cause the current, and resistance will try to stop that current. Potential difference helps in flowing the charges, or helps in to produce and or helps to produce the current, and resistance will try to stop that current. So potential difference is directly proportional to the current. When potential difference is higher, current is higher. When potential difference is lesser, current is also lesser. Another name for potential difference is voltage. I am sure all of you have heard of the word voltage, right? When voltage is greater, then current is also greater, right? So potential difference directly proportional to the current. So these are three things we need to know about before we start this experiment. And uh, no need to worry. I will describe these three topics briefly in the current electricity chapter in our theory. Okay, so these are the apparatus required to do this experiment. First of all, a battery, an insulated copper wire, a key, an emitter, and a voltmeter, a rheostat, a resistor, a piece of sandpaper. These are the apparatus required to do this experiment. Next, the theory of this experiment. Theory of this experiment is that in an electric circuit, the potential difference V across the metallic wire is directly proportional to the current flowing through the circuit with a constant temperature. This is known as the Ohm's law. So, according to the theory, current potential difference is directly proportional to the current, which is given by Ohm's. Ohm. That's why this is also called Ohm's law. Ohm's law is the most important law in electricity. Without knowing Ohm's law, we cannot study electricity. So all of you have to remember this law, that potential difference is directly proportional to the current. So therefore, what V is for voltage or potential difference. Potential difference is directly proportional to the current. V proportional to I. Okay, so according to the theory, V is proportional to I. Okay, so we cannot get a particular value of potential difference or I with the proportionality sign. So we have to remove that sign. To remove that sign, we have to put some constant. We put R as the constant. V equal to IR. Here R is the resistance of the circuit. The material has its own resistance also, and we can put resistance from outside. The rheostat is a variable resistor. So the resistance we apply from the outside with the help of the rheostat. Ammeter will measure the current, voltmeter will measure the voltage or potential difference. Okay. The following are the factors affecting resistance. First one is the nature of the resistors. I have already told you nature is the material. Okay, so resistance will always depend on the material. See, usually we use copper wire in our electrical devices because the copper wire has really low resistivity. So because of copper wire has really low resistivity, it will help the we will get more current. So in electrical devices we use copper wire. So some material has really high resistance, so those material are not helpful to get more current. Next is with an increase in length, the resistance also increases, so length also affect in resistance. With the increase of length, resistance increases. With the increase of cross-sectional area, the resistance decreases. So cross-sectional area of the wire affects the resistance. So when the cross-sectional area is wider, the charges have more area to pass through. So that's why with the increase of cross-sectional area, resistance decreases. So these are the factors which affects resistance. First one is the material, second one is length, third one is cross-sectional area. With the increase of length, resistance increases, and with the increase of cross-sectional area, resistance decreases. And the material which has lower resistivity is the copper. So in your practical copy, first you have to write down the aim, then apparatus, then the theory. Table and the graph I will share later. And about the graph, first we have to change the current with in an meter bridge. We will take a meter bridge to do this experiment, and we will change the current, and we will see the effect of voltage due to the change of current. So we will increase the current and see what is the value of the voltage with the help of the voltmeter, and we will write down the values of current and potential difference, and we will put these values in a current versus voltage graph, I versus V graph, and that from that graph we will calculate the resistance of the material. So this is to find out the main aim of the experiment is to find out the resistance. So do you have any doubt or question? All of you have understood this experiment? Say yes, no, or if you have question, you can ask.
Yes, ma'am.
You have understood this experiment?
Yes.
Okay, so now in your practical copy, you write down this experiment, aim, apparatus, and theory, table, and the graph. I will say share later, and you submit this experiment by 2 p.m. Okay. This is your classwork for today. You have to submit this experiment. Give me your attendance in the chat box. तुम लोग जो कुछ रिप्लाई नहीं करते हो तो हम मुझे कैसे पता चलेगा कि तुम्हें ये एक्सपेरिमेंट समझ में आया है नहीं आया है? तुम लोगों को कुछ बोलना चाहिए ना. तुम लोग सेक्शन सी के लोग कभी कुछ रिप्लाई नहीं करते हो. ऐसा क्यों है? अटेंडेंस मांगू तो तुम लोग दे देते हो पूरा, लेकिन मुंह से कुछ नहीं बोलते हो. कुछ समझ में भी नहीं आता है तुम लोगों को समझ में आया कि नहीं आया. Okay, Sears, please collect the attendance.
Ma'am,
Yes.
do we need to take screenshot to write this experiment?
I will share the PDF file in your WhatsApp group.
Okay, ma'am, thank you.
Ma'am,
Yes.
what is sandpaper?
Sandpaper is used to make the material smoother.
Okay.
If there are some junk in the wire, the sandpaper is used to remove that.
Thank you, ma'am.
Okay, CR, please collect the attendance. Okay, now I will share the PDF file in your WhatsApp group. Write down the experiment in your practical copy and submit to me. And you can leave the meeting and start writing the experiment. Thank you.
Thank you, ma'am.